Hello, welcome to this session. This is the netapp E-series systems from netapp compared to JBoss. Okay, so there is a lot of talks about why E-series versus JBoss, why JBoss seems to be less expensive than E-series. A lot of questions around. For the people who doesn't know me, my name is Didier Gava. Seems to be French, but I'm not French. I'm Belgian. Speaking French, but not French. So all the jokes you can do on the French, I don't care. And yesterday night I went to the pub with my friend from Logicom, and they were teasing French, but I was laughing, but not. You know how to put the three words green, pink, and I don't remember the colors. This is French jokes from Romanian to English joke from my friend from Romania. If it will be in the room, he will tell about this joke. I will ask him. The three colors. Remember the three colors? Green, pink, and yellow. So at netapp, I'm a storage solution architect. That means I'm building solution around E-series and the software you want to put. Could be Hadoop, could be Splunk, could be whatever you want, so I can build the solution with you. On the JBoss, why people is using JBoss? Because it's commodity hardware. It seems to be cheap when you are comparing the price of E-series, even if it's the lowest entry level, to a JBoss. You say, oh, netapp is expensive, but netapp is not so expensive. I don't know what is the word expensive compared to, but you have two views. The view of getting a design, a long-term design on your system, or buying pieces and building by your own. So this is the way of building our architecture. You can build on the commodity server. This is your what you do. You do your own support, you do your own purchase, and you build yourself. Or you take the high-value infrastructure. So you have an E-series. I won't talk about fast because fast will not enter in this category. Why? Because fast is more oriented to features and to file. The E-series is oriented to block device. You have three products: the 2000 product line, the 5000 product line, and the EF product line, the full flash product line. So whatever is the option you want, we have a solution. So when you are using white boxes, JBoss, what does it mean is you have to create your own design. You need to buy your servers, you need to buy your JBoss, your drive, and because you want some protections, you have to do 3 copies. And I will tell you why I always talk about 3 copies. Then you need to use the erasure coding. Do you know what is erasure coding? No? So the erasure coding is a protection of data based on duplicated, or basically doing the read protection on several servers. So you have, imagine you have, you know, the RAID 5. So it's RAID 5 is n data disk plus 1 parity disk. RAID 6 is n data disk plus 2 parity disk. And the erasure coding will be n server data servers plus parity servers. So you can do, when you send your data, the data will be chunked in pieces and it will be written on several servers. This is the erasure coding behind. So to summarize, the red is a subset of erasure coding. Erasure coding have more feature sets, but the red can be assimilated to erasure coding. So you are using the commodity hardware. You have no high availability. Why? Because you get your JBot attached to your server, and guess what? What's happened if your server collapses? If you don't have any duplication, you lose the access of your data. That's why you get 3 copies. The support, when you have a problem, if you call the white box vendor, I have a problem, says buy another drive, buy another enclosure. That's what about the support. Or the simple answer is do it yourself or help yourself. If you do E-series, on the E-series is the same. You can build by your own. You need to have 1 or 2 servers, and you can have 1 or 2 E-series for your protection. You want the maximum security, you can have 2 E-series, but the simplest building block is 1 E-series, 2 servers to have a high availability. If one server has a problem, you still have access by the second one. The hardware is 5 nines. What does it mean 5 nines? Is 5 minutes downtime per year. So the E-series was designed, and the design is 25 years old design and still in progress. And everything is hot swappable, and everything, even if you have a signal integrity on the backend, the controller, the E-series, can fix the problem by itself, and they will just send you a notification says, be aware, you get the signal integrity, but I fix it. In terms of copy, instead of getting 3 copies, we get 1.11 or 2.23 copies, depending the protection scheme you are using. So red 5, red 6, or dynamic display. We use dual priority protection, and what does it mean? You can fail 2 drives at the same time, and the system can survive. With dynamic disk pool, and if you Google on YouTube, there is netapp DDP or netapp dynamic disk pool. There is a video explaining you how works dynamic disk pool. And the first word from the marketing guys said, don't do it at home. Basically, he configured 2 identical systems, one with DDP, one with the classical red 6. They removed 2 drives on each system. And on BDP, they remove up to 4 drives, and the system is still generating IOs. And they will explain you why you can survive sequential drive failure in the system with dynamic disk pool. The misbehaving drive detection, that means the drive sometimes is slowing down, and the performances is not there. The system can notify that the drive is slowing down, and it will make some testing. It can reset the drive, so reboot the drive, and if the drive is not working properly, it will be ejected from the system and will be failed, and the reconstruction can start. Performances will be consistent. Why? Because the red engine is inside the storage, and if it's inside the storage, it will deal with the data, and if it's on the server side, the server needs to share the resources between the RAID and the application. Also, the scaling is important. The scaling, you can add more system, or you can add more enclosures, more JBot to the what I call RBot. RBot is the controller is inside the enclosure, and you can have more capacity behind the system without any drop of performance. Reducing the traffic network, what does it mean behind is when you have a drive failure, what's happened on our JBot system, you have 3 copies, you have one drive failed, and you need to use the network route to duplicate your data on the new drive. So what does that mean? If you have the bandwidth allocated for your data traffic, if you have a drive failure, instead of getting 100% of the data traffic, you will get maybe 80, 60%, depending the QoS you put on your JBOD, and the performances will be reduced by drive failure. On the E-series, you have a failed drive. Guess what? The controller will take care about the failed drive. It will not impact the traffic. And the space and OpEx efficiency means we have for you enclosure 60 drive, and if we are using nearline SAS drive, we can have in row close to 500 terabyte within for you. This is raw. Actually, it's 480, 60 times 8, but removing the parities and all the conversion base 2 to base 10, it's a bit below that numbers. But even with the overhead removal, we are around 400 terabyte per folio. So why 3 copies? So this is from Ceph, and Ceph states by default we need 3 replicates. This is the Ceph statement, and this is where we are talking about the 3 copies with the white boxes. This is a standard built by Ceph, and guess what? When you are here, number of copies is 4. So Ceph is a software, and they are putting blocks on different servers, and they need by default 3 copies to survive problems, but they put 4 as a parameter, so you get 4 copies. So you need to oversize 4 times your capacity. So when we're talking the redundancy model, what we have is our JBOD. We're talking about the capacity, the performances, efficiency, availability, and the data integrity. This is important. Data integrity is how confident I am with my data. Is my data corrupted for some many reason, or if I have a corrupted data but I don't care. But I think all users or company cares about the data, because the data is the heart of the company. So when we're talking about JBOD, performances, availability, they are there because we do copies, but efficiency, it's not there because we need more servers, we need more drive to satisfy the capacity and the performance. Data integrity is building inside the file system. If the file system or the application is not aware about corruption, guess what? It will transport the corruption. And the example I used to take is the Ariane 5 rocket. When they send from the rocket, and it was 20 years ago, they send a rocket and they get a problem with one computer, but they have the spare system, which is the same spare system as the primary one. Primary one has a buffer overload, and guess what? The second one has also a buffer overload. So the rocket exploded in the sky, and it was in 1995 something. And because they are confident in their system, they just duplicate the system, but they forget to have to think about the buffer overload. So we get the same with the JBOD. With the E-series, we use the same, so we get our 2 servers. Usability, we have 11% overhead, but the data integrity and the availability and the efficiency is inside the storage. Also, we get the second one with the 2 systems. So we get one E-series, one server, another E-series, another server, and we have the same efficiency, except we have 2.33x usable capacity instead of 1.11. And also we get the cloud services, but this model, when you send your data to the cloud, and if you have a Mac, you get your iCloud account, you send your data somewhere, but you don't know where is your data. And how will be the performances grabbing the data from the cloud, and what will be the integrity on your cloud. This is the question mark we have. So then, when we are talking about and I will go through one example, we have some details with two servers and one connected to one E-series controller. So the E-series has two controllers on the back. And with the light, we don't see the picture, but we have two controllers, so we connect our two servers to the two controllers, and the enclosures is the same for all the E-series product line. So you can add expansion and it will be the same chassis, but instead of getting controllers, we get IO modules. And the MTBF we get of that configuration, it's about 10,000 hours. If you are using 3 single servers, so JBot attached to servers, we get 3 copies, and the MTBF configuration is close to 2,000 hours. So what does it mean in terms of reliability is you have more chances to have failures on your JBot than on the E-series. So when we use 2700. The 2700 is our entry level storage, and we do 216 terabytes raw usable capacity. So with the JBot, we need from 3 to 6 copies, and for us, we go from 1 or 2 copies with maximum 20% uplift for redundancy. So what we use is only 60 drive, 54 disks for data, and the rest for the priorities. On the system, we use 54 disks per node, and we get 108 disks for priorities, for redundancy, and in total 162 drives. That's compared to 60. Then the performances will be stronger. What does that mean is the performances will be the performances from the servers, the connection from the servers to the disk. And you can go faster than the limit. And when you have a problem, the synchronization between two data will take ages. Then, when you want to group your system, because you start with three nodes, but you want to add more compute power, guess what? You need to buy space, because JBot is sold with the servers. If you want to have more capacity, you need to add more compute power. What does that mean is you increase the layer of complexity. When you are going to the E-series, the performances can be shared. You can have more servers talking to the system. And also, if you have a problem, you have the support from netapp. You call and I have a problem, or auto support is enabled. The support find a problem, they will ship you a drive, and the drive can be replaced on site or by your technician, which will replace the drive. So when we go about the acquisition, so the cost will be lower on JBot compared to the E-series. But why? Because we use commodity component, and the commodity component is a lower class of component. It can fail at any time. Replacement rate is higher. Why? Because by nature, the components are not designed to work 24/7, and the system will collapse. And your system, because you add more bricks, you will add more complexity, and more complexity leads to more problems. With the E-series, the system is robust, and as I said in the previous presentation, we ship since 5 years more than 1 million systems. That means we produce 3,000 a week, and if we know that we have a hardware or software issue, we will know it immediately. And why it's a bit costly? Because the components are more, we use series component. But on the other hand, we need less system, so less power, less cooling for the data center. When we're talking about data integrity, as I said, you need to assume that your file system knows about the integrity, and you need to correct the integrity. If the error is there, you need, and it will be propagated because we just copy, but we will not check the data or the portion of the data. And if we have an issue with the component, we need a full resync of that component instead of rebuilding outside the network, and we use less network traffic. Also maintenance, because you know the hardware is living, and what about your JBOD when you want to upgrade the code, changing the HBA? This takes a downtime. On the E-series, everything done within the storage is online, so you can upgrade the code of the controllers online. Even the drive code can be done online. If you have expansion, you have IO module cards, can be online upgradable. So you have zero downtime when you do a maintenance on the system. Because you get 2 servers, so you can do the failover on each server. You can upgrade the HBA, driver, software on one server. All the IO go on the other one, and you do the reverse to make it everybody on the same page. So this is the model I want to share with you. So this is the assumption we have. We get the cost with the energy of 10 cents. This is the US numbers. We get the cooling also numbers. We get the cost for the servers and the software management. We get also the cost by the square meter in the data center. And also we get the warranty cost on the E-series included for 5 years. So we did the TCO for 5 years. And this is the numbers we get. So we saw that we have the MTBF here. So 10,000 for E-series, 2,000 for JBOD. And what we see here is 80,000 for 2700, but it will cost you more with the JBOD to get the same class of services. And when you add all the drive, all the warranty, we get 55,000 US, and with the JBOD 73,000. So you think that JBOD is less expensive than an E-series? This shows that that's not the truth over 5 years. And if you want to do 2 nodes, 2 copies with E-series, so 2 E-series, you want the maximum protection, so you get 93,000 and still 73,000 with the JBOD. So when you calculate the TCO, we saw in green what is with the JBOD. Light blue is 1 E-series, 2 servers, and dark blue is 1 E-series, 1 servers multiplied by 2. So this is the TCO, and we see that after year 3, JBot is more expensive in terms of TCO. So the person who are calculating the total cost of ownership, adding, actually you need to add different components, and I will show you on the next slide. The accumulation of hardware, software maintenance, and human power need to maintain your system will be more costly with JBot rather than with the e-service. And here is the same slide, but shared by 3 parts. So the blue column are the hardware, so the hardware remains the same. But over time, because drives are failing, so more drive is failing, more people is needed to replace the drive. On the JBot, when you have a drive failure, guess what? You need to enter the system, spotting which drive has a problem. Oops. Which drive has a problem, and after sending the guides, changing the drive. E-series, you have a drive, you get an alert from the console, and you can spot clicking on the drive stating this is the location of the drive and you need to fix it. The red is the power and cooling requirement. So basically, at the beginning, you have a couple of servers, a couple of storages, and the cooling costs you X. But over the time, you need to add more storage, more compute power, so the cooling will be increased. And as I said, if you want more space, you need to have more CPU, because both are tight. You want more capacity, you need to add more CPU. And you increase the cooling and space requirement because nothing is tight. The software maintenance and maintenance operation is growing and growing. Why? Because you add more servers, so you add more software. You add maintenance software. If you want to use Red Hat, for example, Red Hat you need to pay per CPU per processor. If you want to have support on the Linux per system, for example, or if it's Windows need to be paid a fee for the maintenance. And also, if you get a failure, you need to have more person, or the same guy need to work harder even during the middle of the night when you get a failure. And this failure will be checked by the person running on all the data centers and replacing the drive. As I said, the MTBF is 2000, so using lower quality of drive means more problem and more failure. And after year 1 and year 2, it's okay, but year 5, the drive will be replaced almost every week. With the E-series, we have statistics. We have a center who was using 60,000 drives, 60 and 30, 60,000 drives with the E-series. And guess what? The failure rate is below 2%. 2% is what the drive vendor states. And on a batch of 25,000 disks, we lost in 2 years only 200 disks. And the failure on that side is the drive is slowing down the file system out. The drive didn't, when I read the firmware, it's not responding out. And when we compare the failure, the real failure when we have a problem, it's 10% of the batch. So out of the 200 disks, we get only 20 disks with real failure. This is the quality of the drive we put on the E-series. We want to get the data integrity at the big level, and also reducing the failure rate. Reducing the failure rate is using high quality drive and testing and over testing the drive in our factories. So we have, this is the example I'm talking to. So we use ZFS. How many of you know ZFS? So ZFS is a file system from Sun Microsystem, and now they are owned by Oracle, and ZFS is a file system who do the RAID within the file system. And in the US, when we're talking about what's called Sequoia, is the top HPC center, Laros Livermore. If you type Sequoia, Laros Livermore Laboratory, Research Laboratory, it will explain what you get this. So basically, they take netapp E-series, they have ZFS across RAID 6 because they want to mitigate the risk, because doing everything on the software. And because of the high number of disks, ZFS cannot handle all the problems. And we have the performances with only JBOD, RBOD 120 disks, RBOD with LUNs and the RAID 6 performances. So we get more performances using RAID controller rather than JBOD based on ZFS. This is the example, extreme example that nobody will use it except this crazy guy. But just to let you know that JBOD is good. I have never said that it's bad. It's good for the use you want to use. But E-series with the internal controller will check all the integrity for you, and the performances is much higher on our system. So basically, this is what the decision they took. So they get the RAID 6 is faster on write and double on reads compared to JBOD. And the problem is the ZFS RAID engine has do a lot of work. That's why they get lower performances. So this is my last slide. When we're using the E-series, what is important is not stopping the I/O when we do maintenance. And with the JBOD, you have to stop one node, and after the upgrade, you get the copy back on your node, the resynchronization, and the resync will kill your performances because the network will be used to just synchronize your data. On the E-series, and because the system is designed to be active on the volume side, when you do the upgrade, you get a wizard. So you just click, I want to upgrade the controller, or I want to upgrade the disk. You get something like this. This is for the controller. And guess what? During your upgrade, I/O is running, get the slowdown in terms of performances just because the controller is upgrading, but you still have access to your data. No need to resync because the data is still there and still accessible by the other controller. Questions so far? We get 5 minutes. So the cost. To be honest, I'm not sure because you have a street price, you have end user price, but have I idea? Half. So the cost is the cost will be half of the E-series cost. But as I said, there is I never said that JBOD is worse, even if the demonstration shows that E-series is better than JBOD. But if you have configuration based with 50 terabyte of data, go with JBOD. Why? Because it will be cheaper. But if you go to 200 terabyte, 500 terabyte, 1 petabyte, whatever is the capacity, higher capacity, E-series will be better. 200 terabyte will give you after 2 years the return of your investment. But if it's 500 terabyte or 1 petabyte, the return of investment will be after 1 year. So the threshold I used to say is if it's below 100 terabyte, JBOD will be cheaper, kind of. Above 100 terabyte will be E-series, and you will get your TCO after 3 years. And then will depend on how you want to play with your data, how the integrity is important to you, how the data transfer between nodes is important. Do you think that the JBOD will be faster than E-series? No, because will be bounced by the link from your JBOD to your servers. And if you want more performances, you have to take E-series. Questions or other questions? Before you left, have feedback questionnaires. Feel free to fill up if you are interested by the netapp product. I will be on the Logicam booth. If you have deeper questions on how works dynamic disk pool and other topics you want me to talk about, feel free to see me on the Logicam booth. You'll be more than welcome to answer all your questions. No more questions? Thank you.
Thank you.